We're going to do a couple of sort of mixed questions. They might be using the C formula, might be using the P formula, but they're going to also involve breaking down the question into sort of cases to figure out how to find these numbers. So for this first question, we've got 5 distinct red balls and 7 distinct blue balls in a bag. So they're colored, but maybe they're numbered or something so you can tell them apart otherwise. How many ways can we pull 5 balls from the bag if at least 2 must be red? Okay, so we have to kind of think what this means. It's not like we're just pulling an arbitrary set of 5 balls from the bag. That would just be 12, the total number of balls, choose 5. We could just plug that in. But we do have this restriction that we need to be mindful of here, that 2 must be red. So we need to think about what that actually means. Well, if, at least 2 must be red. We can break that down into manageable cases. So case 1 would be 2 are red, or we could have 3 are red, or we could have 4 are red, or we could have 5 are red. And that is the word or between them all. So what we're going to do is find these numbers and add them together. So 2 red, 3 red, 4 red, and 5 red. So if there's 2 red, then because I'm pulling out 5 balls, that does tell us then that there's 3 that are blue. For example, if 3 are red, then there's 2 blue. If 4 are red, then there's 1 blue. And if 5 are red, then there's 0 blue. And so basically what we need to do is just figure out how many of each ball that we're going to get for these cases. So if I've got 5 balls in total and 2 of them are red, that's going to be 5 choose 2. And if I have 7 balls in total and 3 of them are blue, that's going to be 7 choose 3. I don't know why I wrote that so funny. But we should be able to figure out those numbers. We can think of this as a process of getting our red balls, then getting our blue ones. So 5 choose 2 should be 10. And 7 choose 3 is 35. And if you like, we can write the word then in between, because then we just end up sort of jumbling them all up. The order doesn't really matter. So it's going to be times. So case 1 has 350 possibilities. Make that look a little more like a 5. And then we just do the same thing for all of these. So 2 red is going to be 5C2. It's 3 red, 7C2. Give myself a bit more space for my answers here. And so that one is, I don't know off the top of my head, that one should also be 10. 7 choose 2 is 21. So this one is 210. In the 3 red case, the 4 red case, well, there's 5 ways to do that. And if we get exactly 1 blue, that's going to be 7 ways to do that. 7 choose 1. And then finally, if they're all red, there should just be 1 way to do that, and that's by choosing all of the red balls. And there's only 1 way to choose no blue balls, and that's by not choosing any of them. And so we get exactly 1 of those options. And so in total, we are now doing cases. So because it's cases, it's that word or in between all of them. And so we'd add these up and get our total of 596 ways to do this. So that's option 1 for solving this problem. There's another way that we could do this, and that might be a little bit faster in this case, and it's to sort of work backwards. So I'm going to do this a second way, and hopefully we get the same answer. All right, so the other way we could think of this is everything but the 1 red and the 0 red case. Right, so everything except those cases. So what we might want to do first is find the everything. So that would be all the possible ways of doing this. And that's where we don't care about color. So the everything is the 5 plus 7 balls total. And we're choosing 5. So that will be 12, choose 5. Is 792. And then we're going to deal with the 2 sort of reject cases. So we'd have 0 red, which means that all 5 are blue. And then the other reject case would be 1 red, which means that 4 remaining ones are blue. And it's just the same calculations as doing it the other way. So 0 red would be 5 choose 0. There's only one way. And then 5 blue would be 7 choose 5, which I think was 21. Yeah. So in total, that's 21. And then if we add 1 red, that's 5 choose 1 is 5. And 4 blue would be 7 choose 4, which I don't remember what that is, 35. And so when we multiply 35 by 5, the total number of ways to do it that way, that's 175. And so what we get is 792 minus the total minus the things that we're trying to exclude. And hopefully that works out. Yeah. Wait a minute. I just had a little bit of a panic there, realizing I copied that number wrong. It's 792, not 729. So 792 minus 21 minus 175. We get the same number counting it this way. So sometimes it's a little bit faster. Like in this case, if the number of things you're actually excluding is small, sometimes it's easier to count exclusions rather than inclusions. So sort of thinking backwards. Okay, so for a second question, we're going to use the digits 1, 3, 5, 7, 9. So your odd digits and no repetition. So they're only showing up once. You can only use it once. How many 4-digit numbers can you make that are greater than 5,400? So when we think about this, basically we need to kind of think about what are the possibilities for the first digit. Well, I know it can't be 1 or 3. So it's either 5, 7, or 9. But then from there are different possibilities for the second digit depending on what you chose for that first one. So for example, if you chose 7 or 9 for the first digit, the number is automatically going to be bigger than this 5,400 because the first digit's bigger. But if you chose a 5, you have to be a little bit more careful. So what we're going to do is split this into 2 cases. So case 1 is going to be 5 as the first digit. And case 2 is going to be 7 or 9 for the first digit. So notice that's 2 possibilities. So in that second case, it is a little bit easier because then the remaining numbers don't matter. So for my second digit, for example, I guess I'll start with my first digit. There's 2 possibilities, 7 or 9. And then my second digit, I've chosen the first one. I have 4 left because if I choose 7, I can choose from any of the other numbers for my next digit. And then for my third digit, I've chosen 2, so I have 3 left. And then for my fourth digit, I only have 2 left over from what's been chosen here. So we can work that out, 2 by 4 by 3 by 2 to get 48. Now, if 5 is the first digit, that only gives us one possibility for that second digit. I'm going to actually just fix my bracket there. Okay. Now, my second digit, I do have restrictions here. So for the second digit, if I want it to be bigger than 5,400, the second digit must be 7 or 9. 5 is already chosen, and it can't be 1 or 3. So there's then 2 possibilities for that second digit. But now if I'm starting with a 5, a 7, or a 5, 9, it no longer matters again. So then I can choose anything that's left for that. And since I picked 2, there's 3 remaining. Now I've chosen 3, so there's 2 remaining. So there's just sort of restrictions in the way that we can do things. But once you kind of identify those restrictions, the calculations are hopefully a little bit more straightforward. And we get this one, that should be a total of 12. And so these are 2 cases, so we add them together. And so we should have 60 for our total number of numbers that we can make from this. So these are typically the types of questions that I do like to ask because they tend to be a little bit more than just plug and chug something into a formula. These are the types of thoughts and thinking patterns that are really, really useful to have to break things down into their simplest components. And like when you have them broken into this component, from that component, it all behaves the same. That's kind of what you're looking for, especially like in programming. If you can do that, it'll dramatically reduce the number of things you have to handle, which is ideal, optimizes efficiency, essentially. So yeah, so there's just a couple of kind of different cases there. One was really more permutation and the other one was more combination, but it's just kind of counting in general, a summary.